In this presentation, I will talk about the preset and clear inputs in flip-flops. They are very important because I will use them in the counters. So let's start with them. They are the direct inputs or overriding inputs or asynchronous inputs. I am calling them the overriding inputs because whenever they come in picture, they will change the output. The Qn will be changed directly. It will not see what is the value of SNR, what is the value of clock. It is changed and it will give a predefined value whenever this preset and clear inputs come in the picture. Therefore I am calling it the overriding inputs. I will tell you how they are changing the outputs, but before that let me tell you what is the asynchronous and synchronous inputs. Asynchronous is preset and clear, whereas synchronous is SR, JK, D and T. You have to keep this thing in your mind. Now this is my SR flip-flop and I will show you where we have to put the preset and where we have to put the clear input. The preset input will go here. This is my preset input and my clear input will go to this NAND gate. This is clear. Now let us see, when preset is 0, what will happen to the output. If it is 0, the output here will always be 1, so Qn will be 1 always. Now when clear is 0, the output here will be 1 and Qn complement is always 1, which means Qn is 0. So we have to see for Qn it is 1 as soon as preset will become 0 and it will become 0 as soon as clear will become 0. So let me write this thing down. Preset equals to 0 implies that Qn is equal to 1. I just explained it here. And when clear is equal to 0, Qn becomes 0 because Qn complement is 1 in that case. So this is important thing that you have to keep in your mind, and let me write one important thing here. Qn is equal to 1 and Qn is equal to 0 when preset is 0 and clear is 0, and it will not see what is the value of S, R, J, K, D and T or whatever be the value of clock. It is going to give this output. So whatever be the value of clock and synchronous inputs, you can write this thing with these cases. The next thing is the block diagram of this whole setup, how it looks. This is the flip-flop, SR, the clock, two outputs Qn complement, and the preset will be given here with this bubble. It shows that it is active low signal. Whenever it is low, the output will be generated, and whenever clear is low, the output will also be generated. So we put bubble here to show that it is an active low signal, and this is the representation with preset and clear inputs. Now we will see the truth table in which the inputs are preset, clear, output is Qn, the two variables, thus we are having 4 combinations 0 1 1 0 1 1. Now let's see what will be the output depending upon these conditions. When preset is 0, clear is 0. It means there is a contradiction. You can see from here, when preset is 0, Qn is 1, and when clear is 0, Qn is 0. So at the same time they are compelling the Qn to become 1 and 0. Therefore it is not used. When preset is 0, Qn is 1, and when clear is 1, it means at this point we are having 0. So the clear has no impact on the circuit, and also you can see when clear is 1, we are having an AND gate, so the output is not affected at all. So Qn is 1 from here. Similarly, when preset is 1, clear is 0, Qn is 0 because preset has no impact on the circuit, whereas clear will make the Qn equals to 0. When both of them are 1 1, it means the flip-flop will perform normally. Okay, from here you can see that when preset is 1, clear is 1, we are having 0, 0. They are not going to change anything in the circuit. And also we can see from this circuit, when preset is 1 and clear is 1, they are not going to affect the value of this NAND gate. So this is all that you need to know about the preset and the clear inputs. We are going to use this preset and clear directly for the designing of the counters. That's why it is important to know these things at this point. So this is all for this presentation.